Okay. So I actually have my doctorate in clinical psychology, and it's from Ohio University. That's where I did my training. But then I kind of took this left turn and decided I really would like to learn about psychiatric epidemiology, which, if you're not familiar with, it's sort of a more global perspective on mental health. So it's looking at, it's looking at how do we decrease the prevalence of suicidality in the U.S. Army. That would be a nice psychiatric epidemiology type question. My current research areas of great interest are trauma and mental health service use. That's what I really find interesting. Um, and I'm actually doing some research right now that relates to assessment and methodology, which has always been loves for me. I'm doing research on malingering, so that's kind of fun. I'm trying to develop a new malingering measure. So because I've always had this love for statistics and research, I've been involved in a lot of weird research, and I'll just share a couple areas with you just for fun. So I did some research on autobiographical memory, on cults, on Pfiesteria neurotoxins, on personality change after stroke, and of course that suicide study I had mentioned a little bit ago about service suicidality in the U.S. Army. That was the study I was involved in too. So anyhow, that's just a little clip about me. I'd love to get to know you guys too, and I've been thinking, how can we do this? Because um, well, I could just ask people to unmute themselves, I guess, and destroy your first name, and then you can hopefully correct me on your first name so I can have that right. So maybe let's try and do that. I'm just going to go in the order that I actually am seeing people on my screen. So Brian, would you mind introducing yourself? Either tell me a little bit about, tell everyone a little bit about your research interest for your dissertation, or if you don't know that, just tell me something interesting about yourself. So your choice.
I'll tell you a little bit about my research interests. So, like you said, my name is Brian. I pretty much know everybody here. My research interests lie in working with children and adolescents who've experienced trauma and working with them on how they can recover from the trauma that they've experienced.
Cool. Very cool. Yeah. Okay, great. Well, thank you. Emily? Hi.
Hi, sorry, I'm on my way back from my horseback riding lesson.
Okay.
The timing didn't work out as well as I was hoping it would. But I'm Emily. My research right now is looking at implementing mindfulness into schools. So we're working on getting it just for the teachers, and hopefully we'll at some point bring it into the classrooms too with the children.
Nice. Very cool. Very interesting. Okay. Well, thank you. Lindsay.
Hi, I'm Lindsay. I just started in Dr. Shivday's lab, so I'm in the very beginning stages, but basically just interested in like adverse childhood experiences and most likely working memory, but still figuring it out, something with cognition.
Okay, cool. Very interesting. Justin?
Hi, I'm Justin. I'm in Dr. Clark's lab right now. I guess the area I'm headed now is I might be doing a meta-analysis on the effectiveness of residential programs. So I'm going to be looking at the individual characteristics of the clients there, the group leader skill and competency, and the group dynamics and kind of makeup of the residential program.
Interesting. So residential for like substance use, or residential for psychiatric needs, or?
So where I kind of got the idea was I worked at Devereaux for a year before I came to Westchester, and I worked at a residential that was all male clients. And they had a lot of behavior issues.
Got it. Yep.
And it wasn't the most ideal experience, I would say. I thought they could have done a lot more to make it better.
Okay. Yeah. Fair enough. Okay. Well, thanks. That's really interesting. Okay. And oh no, people switch positions now. This isn't good. And I'm horrible with faces. Okay. Who Who did I not hear from yet? Jenna, I know I haven't heard from you yet, right?
Yeah.
Okay,
So
good.
I'm actually in the master's program, doing like a second degree. I'm in the Holocaust and Genocide Studies program as well. And my like research interests are in like group processes during genocide. So, yeah.
Okay, cool, cool. Very interesting. Hortensia, am I pronouncing that right?
Yes, that is
Okay.
correct. Um, so I'm a second year student. I know mostly everybody here in this ID program. So my research interest, I'm working with Dr. Griesiak and kind of hoping to start a project using a mindfulness-based intervention for immigrant women.
Oh,
And we're looking at to see if it helps reduce their stress. And we're also going to be looking at possible immigrant-specific trauma that they are going through and see if it also helps with that.
okay. Great. Very cool. Um, so I'm gonna take a guess here. Is it Chica?
Is.
Okay, great.
Hi, I'm Chika. I'm a second year PsyD student. I'm in Dr. Clark's research lab. My current research interests it's with adolescents from like high crime, low income neighborhoods, looking at like the resilience capacity that they have. That's all I can say about it now because I don't know what else.
Yeah,
Yeah.
that's fine. Thank you. That's great. Kind of a cool area. So thanks for sharing. And I know there's one person left and you all switch positions. Is it Erin who I haven't talked with yet?
Yes. Hi.
Okay, great.
I'm Erin. I'm also a second year PsyD student. I work in Deanne Zotter's lab, so I'm interested in eating disorders. And for my dissertation, I'm interested in looking at experiences of internalized weightism and how that affects cognition.
Okay, okay. Interesting, interesting. Okay, I like it. All right, well, thanks for sharing. That's great. So let's thank you for sharing a little bit about your research interest. That's super. It's going to be helpful as we go forward, especially if I continue with you in Sci 602, which probably will happen. It'll be helpful for me to understand where you're heading, so I can help you out in terms of where you're trying to go for your proposals and those sort of things. But I just wanted to get to know you a little bit today, so thanks for sharing. So what I would like to do now is talk through the syllabus a bit, which means I got to get everyone back in line here. Okay, perfect. Yes. Okay, so I don't know if you've had a chance already to breeze through this or not, but I'll just go through it real quick, just to give you a sense for what my plans are for this semester. There's a couple of choice points here, and I will have you kind of weigh in at those points and let me know what you're thinking. So you see my email address, you see my office hours. Of course, because of the whole online thing, I can't just have it doesn't really make sense to have people kind of walk in, so I'm having it scheduled, but it is really easy to schedule. I found this really nice app that seems to do a really nice job. So if you would like to schedule some time with me, oh, someone must have gotten cut off and came back. Okay, if you'd like to schedule some time with me, just go ahead, go to that link, and I'm happy to talk with you then. I'm also generally free like after the class. I think not next week, but in general I am. So, if you want to hang around after class, you're welcome to do that too. Okay, so required materials. So this is I decided to go a little bit differently this semester. There was a book I used last semester, and the first few chapters were honestly okay, but then it kind of, I just found working through it, it wasn't the best one. And so I did find this website that I really liked. It's especially relevant once we get started with SPSS, the computer program, and it's statistics.laird.com. It's not terribly expensive. As you can see, 6-month access costs about $13, although you'll likely want access for both Sci 601 and Sci 602 again. If I'm teaching that, which I think I will be. So anyhow, so get access to that. It's a really nice website, and will basically what it does, let me just give you a little preview, is it will guide you through any procedure, any statistical and analytic procedure using SPSS step by step. And that's why I really like it, because I think it does just such a super job of that. And you'll see that in this class, I'll get to this in a moment, but I'll just give you the preview, that in this class, we're not going to do a whole bunch of formulas. We're not going to do a whole bunch of mathematics here. I want to focus on applied statistics with you guys. If you have a burning desire for some of that other stuff, come talk to me, and I'm sure we can work something out. But for the purposes of the class, that's where I'm heading, okay? Now, let's talk about this next thing, the IBM SPSS Statistics Grad Pack. So, there is a free IBM SPSS Statistics that's available through GramCloud. I don't like it very much. If you have used it in the past, you feel very comfortable with it, you know you're going to be fine with it, use it. But I'm highly recommending you go with buying the SPSS grad pack, and you can see how much the licenses cost. 12-month for premium is about 100, and for standard is about 87. And here's one website where you can get that software. So it's just so much easier to have it on your laptop. I mean, I've had people who just struggle with getting in there and then saving stuff. Again, if you really want to do that, I'm not going to stop you or penalize you, of course. But I decided to make this an emphasis rather than give you an expensive textbook to buy. So that's how I kind of set things up. Now, in terms of equipment, I think it's always good just to have a simple calculator on you. I think it just is a nice little tool to have at your disposal. I did come up with an optional recommended resource if you're the kind of person like I've got to have a book, I've got to have a textbook to look at. If that's you, I'm going to hold it up for you. There is this lovely book by Tabachnik and Fidel, and they've done really nice jobs. I have one of their really, really old ones from like 1984 or something, and they've always done a nice job with their revision. So I like their textbooks. This is the 6th edition I'm holding up. I own the 7th edition too, but like I say here, the 7th edition is newer, but it's more expensive and it's loose leaf bound as opposed to an actual bound book. So I think the 6th edition will meet your needs if you decide you want to go with the text. I think the 6th edition would meet your needs, but you can of course get either one. I'm also listing a couple of useful websites that I like as well, just as other resources for you. Okay. If you're having questions as I go through, please do feel free to take advantage of the chat box. If you're unfamiliar, I always tell people where it is for me, and that's kind of the best I can do. But if you go to the 3 dots by More on your tab and you go up to the top, it should say chat, and you can enter a note to me, and I will, once I get to a good place to pause, I'll be happy to address that. That's true throughout the whole class. If you watch each other, it's possible you might even be able to unmute and talk, or we can try to work something out around that, because there's only 8 of you guys registered for the class. So that may work, but if not, we can always do chat. And then we can like even follow up from the chat of like, let's now unmute and talk. So anyhow, As I said before, as I gave you an idea, this course is going to be an introduction to the fundamentals of applied statistics with an emphasis on the use of statistics in the behavioral sciences. So I give this definition here that I do like. I think it's a nice definition. And I really particularly like one word in it, which I'll emphasize as I read it. Statistics is the science of learning from data and of measuring, controlling, and communicating uncertainty. And it's the uncertainty word I really like, because that's what statistics is all about, right? There's never any definite answer. It's always about probabilities and possibilities. So that's kind of why I like this definition, at least in part. And it thereby provides the navigation essential for controlling the course of scientific and societal advances. So I've already told you that a major emphasis of this course will be on real world applications. And that's the plan, is that you'll spend a great deal of time applying the statistical principles to real life situations. You'll learn how to perform a variety of statistical procedures and how to determine which statistical procedure goes with which type of problem. So as I already said, we're not going to focus on statistical formulas very much or the mathematical theory underlying how they come to be. Instead, we're going to focus a lot on SPSS and how you actually enter data, select an appropriate analysis, interpret the outcome of analyses, that sort of thing. Okay, so that's that piece. Here is my COVID-19 statement, which the first part, of course, is the same across all classes. I'm sure you've seen this a ton of times already. So here's where we get into some of my course format and why I've made certain decisions. So first, I want to be able to give you these lectures synchronously rather than just lecture to, you know, my camera and post it on YouTube. I'm not totally opposed to that, but I think for this class in particular, giving you the opportunity to be here, to ask questions, those sort of things is just really helpful. So that's why I made that call. And I'm also planning to record all sessions in case you can't be here one time, right? Something can come up for all of us. And I would like you then to have the opportunity to not miss the whole lecture and to be able to capture the discussion and everything on YouTube. Assessments, of course, will be completed online. So those are the two points. So this is how I think it would be best to run this. But if you're finding yourself saying, you know, like, let's not record these sessions, and people in the majority kind of agree, we don't have to, but then bear in mind, of course, I'll post slides no matter what, but you know, bear in mind that if you miss a day, you're sort of missing out on the discussion. So I'd rather do that, but I want to, you know, you're grad students, I want to take your thoughts and your opinions to heart here. I wanted to bring that up, that you know, this is the plan for how we run things, but let me know if you're having some, you know, discomfort or disease around that or anything like that. I'll let you read the learning objectives and mission statement on your own. For course format, I'd like to use as much of an interactive lecture style as I can, given our setup. It's so much easier in person, but I'd like to try. So we'll see what we can do about that. And you, of course, are invited to pose questions at any time during class. I seem to get notifications when someone has chatted, so then I can get to those as soon as I can and try and answer your questions. I might have you work in some small groups during class and do those kind of things. Small groups, it's already a small group, but you know, groups of 2 or something like that. So you know, that's the plan here. What else do I want to talk about here? I probably want to talk about assessment a little bit, so let's do that. Exams, 2 in-class exams during the semester. These are the planned dates as well as a comprehensive final, and that's the planned time for that. I, of course, got the time out of our final examination guide. We may have some flexibility, and if you hate that idea of doing it really late at night, we may have some flexibility around that, but we can talk about that a little bit later on. And I'll let you know how we're going to work books and internet and notes and all that kind of thing as we go forward. Homework will be used to reinforce the concept learned in the course. You may need to use, in fact, you will need to use SPSS and interpret SPSS to complete a number of the assignments. Not the first one, for sure. So don't worry about it if you want to take some time getting that. And then the final piece is article evaluation. You'll be reading and evaluating, I say up to 10 just in case other people join. It'll probably be closer to 8 articles because I want one for each of you guys. So the articles are designed to support your understanding of the statistical concepts and analyses. You'll read each article and answer a few questions that I pose, but then every individual will lead a class discussion on an article. And then everyone will be assigned, so you read all of them, but you're assigned one in particular that you lead a little discussion on. That's the idea. And then this is the grading scheme. Homeworks are worth 20, articles worth 20, you see the pattern, in class 20 and 20, and the final is 20. So I just wanted to, of course that means that exams are worth 60%, and so they're more heavily weighted, which you might anticipate in a class like this one, but at least each individual piece is kind of equally weighted. This is the same breakdown that for grad school, that you always see, so nothing special here. And then these are standard policies. The only thing I want to point out is really, well, a couple little things. First, my response to email time. I'm generally checking from 8 to 7 on weekdays. That does not mean if you write me an email at 8 o'clock, I won't respond. It's just I may not be able to. It may be the next day that you get a response. And same with the weekend. So I'm wind up being on email a little more often than this claims, but this is sort of the promise, if you would. But please, of course, feel free to email me anytime you want. This is just, when to anticipate a response. What else here do I want to talk about? I'm flipping through some of this because, of course, it's all good and important pieces of information, but I know you guys are grad students that can read this and go through this and, pose any questions you might have about it. And here is our tentative course outline. That's where we're planning to go, okay? Now, I am certainly hoping that with everything being online, there should be no reason why we won't ever have class. However, it's 2020 and I don't trust anything, so who knows, right? So we'll be flexible if something comes up, but this is the tentative plan. And I also want to be flexible with your guys. Understand, like if you get caught up on a concept and we need to spend more time on it, that's fine. We'll do that. I'd rather do that than jump ahead and miss, something at the end than jump ahead and not have people feeling good about the concepts. All right. So that's all I have on the syllabus. And I think you might have seen that on G2L I posted lecture 1 for you. I'm going to open that, share that in just a second. In fact, let me switch over right now, if I can, to that. There we go. Move this out of the way. Move you out of the way. From beginning. Okay, wonderful. Before I press on to actually getting into the lecture proper for today, let me pause for a minute or two, just check in, see if there's any questions or anything like that that you want to raise at this point in time. Okay, silence so far. So you feel free to do that. I'm gonna take this as a sign that at least not immediately do we have a question. So I'm going to go ahead and press on just a second, but if something comes up for you, please feel free to use that chat function. Happy to answer. Okay. So of course I want to again welcome you to Sci 601. It's the topics are a little bit, yeah, I should have mentioned this. Topics are a little bit reversed in the schedule. Like it says that your first one is more research and the second one is more stats. But as you can tell, the way we've been going through the syllabus and talking, that really this part makes more sense before the other part. So we're going to be talking a lot about stats this semester. Okay. So I will give you a homework assignment at the end of this. It's actually already posted on D2L for you. It's in a PDF document. There's some questions there for you to respond to. So that actually gives me an opportunity to talk about homework a little bit. I want to get you speedy feedback to your homework as much as I can. So here's what I've thought about doing, and this worked really well last year when I taught this class. So what you do is you complete the homeworks, and then we basically would choose. So this time the homeworks go from numbers 2 to 10. Okay, there's no number 1. It goes from 2 to 10. So then what we would do is we would choose a random number between 2 and 10, and I have some random number generators. We would choose a random number, and I'll grade that one for everyone. Now, if you want another one, if you're like, please help me, you got to look at all this stuff, or you got to look at another one for me, just let me know. Just let me know, and I'm happy to do that. But I want to give you, like, in terms of feedback, I want to give you, quick feedback as much as possible. So I think that's the best way to do that. Doesn't mean if you want me to, I won't look at others, or, there was even a time where it was like we picked the number and it was the worst one for everyone, and we might have picked another number. So it's not like I'm trying to like get you here. It's just that I'm trying to, keep it fair and give you that feedback. So that's the plan. Okay. So what I want to start off with is just talking about some research questions and what different statistics we might use to address these. So statistics can be used to answer a variety of research questions, and the choice of statistic depends on these 4 factors here: the research question, how the data were gathered, the data configuration, and the types of variables in the data set. And so we'll talk about all of this as we go forward, because the idea is for you to be able to nicely identify, hey, this is what's going on with this data here. This is the right statistic to use. So I want to give you some just basic examples of this. These are some stats that we're going to be covering throughout the class. So don't worry too much about, understanding all the details of this. This is just to give you some exposure, okay? And then I'll tell you once we get to the stuff that's actually the core that I wanted to talk about today. So this is just some introductory exposure material. And again, I just want to point out one more time, in case someone missed it, that these slides are posted up on D2L. You can grab them, they're in PowerPoint, and you can, write on them or do what you want to modify them. So you don't have to take all this down. Okay. So descriptive statistics, these might have some familiarity, right? You're visually inspecting a series of numbers, and that can be useful for small data sets. It might be less plausible for large data sets to do that, just that simple visual inspection, but there are different descriptive statistics you can use to characterize the data set of any size. So what am I talking about here? I'm talking about things like the mean, the variability, the range, right? those sort of things. And we'll get into more detail about descriptive statistics in a little while, but those are the sort of things we can use to sort of get a basic understanding of our data. And I always say that you're far better off, you know, when you get your data, just take a step back, just try to understand it first. Just try to understand what message it's trying to tell you rather than jumping into some really complicated stats right away. There's always time for that, and that will come. But I always encourage people, do some data checking first and then do some descriptive statistics after that. Okay, and then of course there are graphs like histograms, bar charts that can also provide insight. Okay, so that's descriptives for you. So what kind of questions can we answer with descriptive statistics? What percentage of students graduated? Okay. Yep, we can certainly answer that. What's the lowest, highest, average age? How satisfied are consumers with the product or service? So yeah, we can think about doing a quick percentage. That's the type of statistic we can use. We can do minimum, maximum, mean, median, mode. Those are all averages, if you remember the mean, and we'll talk about those. So don't worry if that's not ringing a bell. And we can look at different levels of satisfaction. We can look at frequencies of satisfaction. Okay, so all different things we can do. All right. So these, now we're getting into some of the actual tests that we're going to learn about this semester. So the t-test and Mann-Whitney U-test, I grouped these together, and there's a reason for that. And I should really say here the t-test for independent samples and the Mann-Whitney U-test, because that's really what I'm talking about, because there are different t-tests out there. But when someone says the t-test and they're not specifying, they typically mean the t-test for independent samples. But anyhow, what you're going to do here is compare scores of two different groups. Could be a control group and a treatment group, and you want to see if there's a difference in their averages. Okay, so those both accomplish the same goal, and the only reason you would use one versus another one has to do with the kind of data you've collected. Okay, and we'll talk more about that when we get there, but you know, most people have heard of the t-test for independent samples. Not as many have heard of the Mann-Whitney U-test, and that's because it's we always tend to assume normality even when sometimes we shouldn't. And so a lot of the stats you've probably heard about are all assuming this normality. But in real life, we don't always have that. So it's nice to have these statistics that don't assume that, and Mann-Whitney U is one of those. So one of my goals for the semester is to be able to give you information about the typical stats that you use if you have normality, as well as the maybe less well-known ones that you use if you don't have that. Okay. So what kind of questions can we answer with the t-test or Mann-Whitney U-test? What's the best way to teach a subject? Method A or method B? Which drug produces the best result? Placebo or drug A, which is 20 milligrams? Which lighting source enables fastest reading? Regular room lighting or the Acme reading lamp? So you notice in each of those cases, what are we doing? We're comparing two different groups, right? One group that was taught with method A, another group that was taught with method B. And that's the basic idea here. Okay. Paired t-test, or you might have heard of this as the dependent samples t-test. That's another name for this. And the Wilcoxon test. Now, this is similar to the t-test for independent samples, but instead of two groups, the sample is contained within a single group. So in this case, what you have is pre-test, treatment, post-test. So in other words, we're going to test your knowledge of biology at the beginning of the year. You're going to then take a course in biology, and then we'll test your knowledge afterwards, right? So that sort of idea. So let's look at some types of examples of that. Does chocolate cake improve mood? So again, we would test mood, we would assess mood at the beginning, administer the chocolate cake, and look at the mood again. Okay, does a change in lighting enhance productivity? Does a treatment reduce a fever? All of these are looking at changes over time or some kind of change type mechanism where we're trying to understand pre-treatment, post. Okay, so it's the same people who are getting the pre and post test. This is actually a little bit of a stronger type of test than the independent samples t-test in terms of just the analysis, in terms of your power, if you will. But the hard part about it is getting people back. You know, actually retaining your participants to do a pre-test method and post-test. But if you can do that, it's a little bit stronger. Okay, the ANOVA and Kruskal-Wallis test. Now this is similar to the t-test for independent samples, but the only difference is that now we have 3 or more groups. Remember before we had method A and method B? Now it would be method A, method B, method C, and if you'd like, method D. So it usually involves a control group and 2 or more treatment groups. And again, we're comparing averages. Okay, all right. So what kind of questions can we answer here? What's the best way to teach a subject? As I said, method A, method B, method C. Which drug produces the best result? Placebo, drug A with 20 milligrams, or drug A with 40 milligrams, or drug A with 60 milligrams, if you like. What lighting source enables the fastest reading of regular room lighting, Acme reading lamp, or generic reading lamp? Okay, so all the examples here are 3, but just bear in mind you can do as many groups as you like here. The only limitation, of course, is your participants and therefore your power. Okay, and don't worry, we'll come back to these concepts like power and participant power and those sort of things. So ANCOVA is the same as ANOVA, but it controls for an identified covariate. I'm just gonna take 1 second and try and kill this thing. Okay, good. Sorry about that. I don't know if you're hearing the background noise as much as I am, but I wanted to make sure in case you were hearing that ringing that I stopped it. So sorry, ANCOVA is the same as ANOVA, but controls for identified covariate, like a confounding variable. So let's look at an example of this. What is the best way to teach a subject? Method A, method B, method C, given a student's age? Which drug produces the best result? Placebo, drug A, or drug B, given the number of missed dosages? Which tutoring program? Program 1, Program 2, or Program 3, or Program 4, remember we can have more than 3 groups here, produces the best grades taking into account class size. So whenever there's another variable that you're trying to take into account that might be a confounding variable, and we'll talk more about what confounding actually is, that's when you want the ANCOVA. Okay. ANOVA repeated measures. It's similar to the paired t-test, but instead of gathering data from the single group at 2 time points, pre-test and post-test, this data gathers data repeatedly over 3 or more time points. So in other words, an example might be if you're looking at post-traumatic stress after being burned from a fire, you might want to look at people immediately, like when they've gotten out of the hospital, discharged from the hospital, then maybe 2 months out, 4 months out, 6 months out. That would be an ANOVA repeated measures. Okay. So is a 6-week course of antidepressive therapy effective in elevating mood as measured at weeks 1, 3, and 6. So you've got the same people, right? Same people, and you're just measuring them at these different time points. Does 60 minutes of meditation reduce pulse rates as measured at 20, 40, and 60 minutes? And does a smoking cessation program affect daily smoking at weeks 1, 2, and 3? So again, similar to the t-test for dependent samples or the paired t-test, this is again a little stronger. Whenever you can retain your same participants, it kind of means that they're serving as controls for themselves, so you don't run into the problem of what if you wind up, when you're comparing two separate groups, let's say I'm comparing two groups for their learning, and one gets method A and one gets method B. The problem could be is that what if my method A group happens to already be like these learners who just excel, right? And my method B is less of that. Then maybe it's not the method, maybe it's the actual student that's actually causing the result. And that's the error associated with statistics. So when you're comparing people just to themselves, you don't have to worry about that. Okay, so just putting that out there. Okay. MANOVA, it's the same as ANOVA, but with 2 or more outcome variables. Notice up until now, we've only talked about one possible outcome variable. Which is the best way to teach a subject, method A, method B, method C, and which is the promptest? Which drug produces the best result, placebo, drug A, or drug B, and which produces the fewest side effects? So we're looking for maybe greatest reduction in symptoms and lowest side effects. 2 different outcomes. What tutoring program, program 1, program 2, or program 3, produces the best grades and the highest self-esteem? See again, best grades, highest self-esteem, 2 outcomes. And you can have more than 2 outcomes as well. Again, a lot of this, the fancier statistics sound really great because they can answer such, more interesting, better questions, but then you need more people for them. And you got to have the participants or it kind of falls apart. Okay. Correlation and regression, and we're talking about Pearson and Spearman correlation here, where you're comparing 2 continuous variables to determine their relationship to each other. So, for example, what's the relationship between grade and homework hours? What's the relationship between income and happiness? And what's the relationship between height and self-esteem? So if you're talking about correlation, you're just talking about the relationship. Just what's the strength of the relationship between these 2 things. When you're talking about regression, you're talking a little bit more about prediction. You want to be able to say, oh, a person who gets a grade of X will likely have put in Y homework hours. Okay, so correlation tends to be just association, whereas regression tends to be prediction as well. Okay. Multiple regression. Which variables predict a continuous outcome? It's still just one outcome, okay? MANOVA is the only one we've talked about with more than one outcome. So let me show you these kind of questions. Which variables, age, gender, income, education level, race, predict happiness? Which variables, age, gender, income, education level, race, weight, height, parents' length of life, predict length of life? Now, just because the variables are being tested, that doesn't mean they're significant. And this, this is just trying to provide some sort of example of things that people are generally interested in looking at. So a lot of times demographics are things you want to either investigate or control for. So it wouldn't surprise me, like in that latter question, if you really thought that parents' length of life would predict the next generation length of life, but you wanted to include some other variables to sort of control for them, take them into account. Okay, all right. And chi-square compares categorical variables to detect differences in proportions among categories. So chi-square isn't too popular just because it's not considered an extremely elaborate statistic, but let me show you some questions. Is gender, in this case, it could be as actually, let me point out with chi-square, you can actually have as many genders as you like here. I just put down 2. Associated with ice cream flavor preference, again, you could have as many ice cream flavors as you like. I just put down 3. Okay. Same thing here. Is parents' marital status associated with high school graduation of their children? The thing to really notice here is we've got categories in both variables, right? Marital status, married, single. Again, you could have as many marital status options as you like. Associated with high school graduation, either graduated or not graduated. And is handedness, right, left, ambidextrous, associated with academic achievement? We're looking at different levels. Sorry, there should be a PSY there along with that PhD. Okay, so hopefully that gives you a sense for those. Last one, I believe, is logistic regression. Okay, so imagine a chi-square, but you have more variables you're interested in studying. So now you want to do this chi-square. You've got a 2-category outcome. That's what, so 2-option outcome. So in this case, let's say, is handedness associated with, no, let's do is parents' marital status associated with high school graduation of their children, graduated, not graduated. Okay, but now you can add in more independent or variables here. So you can say, is the marital status or gender or ice cream flavor preference all associated with high school graduation of their children, graduated or not graduated. So that's what the logistic regression can do. It really amps up the power of a chi-square. Okay. So again, and here's some questions answers. What are the odds of getting the flu, sick or not sick, for gender, age, and ethnicity? What are the odds of opting to be an organ donor, donor, not donor, for gender, age, ethnicity, religion, and disease? What are the odds of voting in an election, vote, does not vote, based on, again, all of these different types of variables? So that's the power of logistic regression. Okay, so I'm only sharing with you 2 different kinds of regression. There are actually many, many kinds of regression, and it just depends on, again, the kind of data you have. So, but I don't want to get into all of those, but what I guess I want to get at is that regardless of what your research question is, there is a stat out there to help you out with it, to help you answer the right question. So usually it's as long as you have the participants, there is a stat to support it. Okay. All right, now we're getting into the proper part. So again, that first part, I wanted to give you some exposure. Hopefully it gives you an idea of some of the stuff we're looking to cover this semester. But now I want to actually start talking about some material that, it's actually a little bit more into the course. So, I'm going to continue to leave the chat open. If you have any questions, please feel free to type in. So let's talk a little bit about populations and samples. Now, I am taking you from the beginning here. So if you feel like you already know this, that's fine. Just kind of sit back, enjoy. But I want to take you from the very beginning just to keep us all on the same page. Okay, so here is a population. Here is a sample. So if you look at these, you sort of start realizing there's some interesting properties going on. First of all, the sample is the same shape as the population, right? And it looks like it's a little piece of the population, both of which are true, right? So both of which are kind of truisms about the relationship of population to sample. So to more formally define it, population is the entire set of things of interest, like the entire population of individuals in the US or the entire population of children with autism. Whereas the sample is that small part of the population about which you actually have information. Let's say the 1,000, and again, I'm just saying men and women for ease here, but it could be anything you want, 1,000 people who answered an online questionnaire about mental health care usage. 200 children with autism enrolled in an intervention study. That's your sample. That's what you have. Now, there's actually an important assumption that we make about the relationship between sample and population. So I'm going to give you a little silly example. You're in the grocery store. And we'll say it's pre-COVID because I want to use samples here. So you're in the grocery store and it's cereal sample day. And you're kind of hungry. So you say, yeah, I'll take a cereal sample. And there's grain fields being offered today. Very healthy sample, very healthy cereal, excuse me, that has all kinds of grains in there and nuts and berries and all that good stuff. You say, yeah, I'll take a sample. So you take your sample and you eat it, you love it. It's one of the best cereals you ever had. You say, yes, I'll buy a box. You buy a box, you bring it home, you go to eat it the next day, and you're like, what? There's like one type of cornflake in here. There's no nuts, there's no berries. I got ripped off. Right? That's how you would feel, or something along those lines. You would feel like something's not right here because the sample, what I ate in the store, should match the population, the box that I bought. And that's the assumption we're always making, is that our sample should be representative of our population. And hopefully it is, but we can't always guarantee that it is. We're going to talk about some methods that help you draw good samples, help you draw representative samples, but there's never a guarantee that your sample will indeed be representative of the population. Okay. So here we go. We're pulling a sample. I know these are people here, but let's pretend they're marbles just for the sake of argument. And let's say we have some green marbles and some blue marbles and some purple marbles all sitting in a jar, and we pull out 3 marbles. And I'll tell you that in the jar, there's an equal number of blue, green, and purple marbles. So when you pull out a random sample of 3 marbles, what you would expect to happen is get 1 green, 1 blue, 1 purple. But it didn't have to go that way, did it? Right? You certainly could have pulled out 3 green. You certainly could have pulled out 2 blue and a purple. So we're not guaranteed this representative sample, even though most of the time it kind of works out. Okay. So I think you probably already have a sense of this, but why are samples used instead of populations? Because if we use populations, that would be super cool because you wouldn't need all of these inferential statistics we're going to talk about in this course. Because the whole point of those is to generalize from our sample to our population at large. If we don't have to generalize, we don't need all that stuff. You could just use the descriptive statistics and be done. But of course, that's not our life, especially not in the behavioral sciences, where it's just not realistic to get our hands on a whole population of interest typically, right? So we typically conduct research by evaluating a sample of individuals who we hope are representative of population of interest. Okay. So we're always playing this circle game between population and sample. We select a sample from the population, right? And let's say, again, we kind of do it just with a simple random technique where we reach in and we grab, 10 people, right? So if we do that, we hope we get a representative sample, but we have to look at the sample we get and see if it is. So let me give you an example. And someone might be able to actually jump in here if you know, because I know the stats on this have changed or might have changed. So we do know that the diagnosis of autism is more common in males than females, right? So anyone know the rate? That was my question.
I
Like
believe
how?
it's 3-1, like males to females.
3-1, thank you. Okay, so let's say it's 3-1, perfect. So let's say that you want to run a study and you're looking at a behavioral intervention, let's say for children who have been diagnosed with autism. Okay, great. So you go and you reach into your population, you're reaching out, and we'll talk about different ways you might actually, this would be a tough one to actually be able to do just randomly, but let's say you're able to. And you find in your sample that you've only have male children. Just worked out that way. When you generalize back to your population, you shouldn't generalize back to all children. You should just generalize back to the male children with autism, right? That's who you should, because you don't have anyone in your sample that's female. Right? And again, we can do this with any number of genders, and we could play around with this more, but the idea is you've got to look at your sample. You've got to look at who you've got to understand who you can generalize back to. That's the point I'm trying to make here. And I know that sounds incredibly simple, but it's actually one that we tend to make errors with in our field. So always, we get so excited about who our population is and what our study's about and who we're trying to study that sometimes we forget just to make sure we're looking carefully at the different characteristics of our sample and we're generalizing right back to the right population. Okay, so I'll just leave that there. Okay, so with our sampling methods, we hope to get a representative sample, which is a sample that resembles the population. It is always possible that we wind up with a biased sample, a non-representative sample. And the other term I want to talk about here is proximal similarity. Generalization to people, places, settings, etc., similar to those described in the study. That's what we're trying to do. Okay. A few more terms for you, and then we'll get into some other pieces. Sampling error. This is the difference between the value in the sample and the value of the population parameter. Okay, let's take a new example. You're looking at bowling averages, okay? And you do your sample, you find 100 bowlers, they bowl games for you, you get all the averages of each person's game, and you find the average to be around 150. Okay, but then you find out, because there was a very important census done on bowling some years back, and you find out that in the population, the actual average is 220. The difference between 150 and 220 is your sampling error. Okay, the difference between those means would be your sampling error. Okay. So what did you get in the sample? What's the population? Now you might be wondering, what if I don't know what the population is, which we often don't? Then you probably don't know what your sampling error specifically is. You know that there's something out there, but you may not know exactly what it is. Okay, sampling frame, a list of all the items, elements, or people in a population. Okay, something we also may not always have access to. We could though, like let's say we're choosing students from a school at random. Well, we might have a list of the whole school's population, and then when you're choosing, so you would be, in that case, you would have your sampling frame. You would have that list. Okay, response rate is the percentage of persons selected to be in the sample who actually participate. Okay. So we always want more people to participate than usually actually do, and that's what we call our response rate. Okay. So let's talk about our methods of sampling. Again, this might be kind of an old concept to you guys, but let's talk it through. Let's make sure we're all on the same page with this. So I already kind of introduced this one, the simple random sample. This is when basically if you have 12 marbles, and we'll do marbles again, and there are 6 red and 3 green and 3 blue in your population, and you want to choose, you decide you're going to take a sample of 4, you might reach into your bag of 12 marbles, pull out 4, and look what happened here. Half, 6 of 12, of our population was red. Half, 2 of 4, of our sample is red. Same for the blue, right? 3 of 12, or a quarter of our population was blue, a quarter of our sample is blue. Quarter of our population, 3 of 12 is green, a quarter of our sample, 1 out of 4 is green. So that's our simple random sample. So again, I ask you, and I think you have a sense for this, it didn't have to come out this way, right? It didn't have to come out that you got the perfect representative sample of 2 red, a green, and a blue. You could have gotten 4 red. You could have gotten 3 green and a blue. Most of the time, you will get a reasonable representative sample using this technique, but it's not guaranteed. Let's say you wanted to guarantee that you got 2 red and a blue and a green. You might try stratified sampling. So with stratified sampling, you're going to separate the population into groups or strata based on some characteristic, and then take a proportional simple random sample from each group. Okay, so what does that mean? I put my blue marbles in one bag, put my red marbles in a second bag, put my green marbles in a third bag. I'm going to reach into my red marble bag, which has 6, and pull out 2. I'm going to reach into my blue marble bag and pull out 1. I'm going to reach into my green marble bag and pull out 1. So I am guaranteeing the representative sample. So you might be wondering, okay, that's lovely, it's with marbles, it's easy. When might I want to do this? Well, again, when we were talking about that autism example before, that would be a perfect example where you might want to make sure you're grabbing 3 times as many males as you are females. Similarly, let's say you're interested in looking at the military and you want to make sure you're getting a representation of different genders, of different ranks, and those sort of things. Well, you might break them out this way, because if you just did it the standard way, maybe you wouldn't get a full representation of, like, for example, females of high military ranks, because those just aren't as common, so you may not get any if you just reach into the sample and pull out some. So you might break it out to ensure that you're getting a representation of everything. Okay, so that's stratified for you. And that's another cute picture of stratified, but I think you get the idea here. Systematic. A systematic sample is obtained by selecting every kth individual from the population, and the first individual selected corresponds to a random number between 1 and k. Okay, so how does that work? Well, in this case, we decide to take every third one. So, and we're going to start with number 2. So we get number 2, number 5, number 8, and number 11. As you can see, it doesn't work particularly well with the colors necessarily, right? It doesn't work as well as the stratified did in terms of getting a representative sample of our different colored marbles. But it can work well in certain situations. So for example, if you're doing interviews and you want to interview throughout the day, what you might do is use, rather than doing a simple random sample where you could pull out, you know, minute 1, minute 3, minute 5, minute 360, right? That's not too even. You might want to use systematic where you can guarantee that you have an equal interval between your interviewers. Okay, so that's one place where you might use systematic. The place where systematic might fail, I always say, is the example of if you're looking at people in a dorm, and it's a co-ed dorm, and it just so happens that the females are in odd-numbered rooms and the males are in even-numbered rooms, and then you applied systematic sampling. Well, you're either going to get all of one or all of the other, right? Because if you wound up on even, you would do that. If you wound up on odd, so anyhow, that could be a problem depending on how you structured that. So none of these methods is perfect, but they're all trying to help you be able to pull nice random samples. Okay, cluster sampling. Now I want to emphasize the difference between this and stratified, because it could kind of seem the same. So let me emphasize how it's different. This is used, first of all, when the population is already naturally broken up into groups or clusters. And each cluster can be argued to represent the population. That way, we just select a certain number of clusters. So perfect example of this is classrooms in a school. Let's say you want to do a school intervention, okay? And as much as you might like to be able to use a simple random sample and just pull out your students randomly like that, it may be that they say you can only do it at the classroom level. In other words, there's 6 fifth grade classes, and you can actually go ahead and look at 3 of those classes for your intervention, and 3 of the classes will be your control. So what you're doing is you're randomly pulling whole classes at a time with the idea that everyone in the class becomes part of your sample. Okay, so I should have said that there's 20 classrooms. Pull 3 for your intervention, 3 for your control, and there you go. Okay, that makes it a little bit better. So we're actually talking about a sample of 6 classrooms out of the 20. Okay, so the difference again is, first of all, naturally already broken up into clusters, and then once you choose a cluster, it's everyone in that cluster. Remember, we're stratified. We dug into that red bowl and just chose a couple out of there. That's what's different. We didn't choose all the red. We just chose a couple out of the red. Okay, so hopefully that helps. If you'd like more clarification on the issue, just chat in there. I'm happy to talk about it more. Let's get to the end of sampling and then take a bit of a break if you're interested. Sound good? Yeah, okay. At least I saw a nod or two, so let's do that. Haphazard selection or convenience sampling. This is a method of selecting a sample of individuals to study by taking whoever is available who happens to be first on the list. And this method of selection can result in a sample that's not representative of the population. So you look at your list of students and you say, oh, it's kind of a bother to do a full random sample here. What I'll just do is I'll take the first ones to arrive tomorrow. And I imagine you can think of some problems with that. Maybe you can maybe someone can jump in here and either speak to or chat in what might be a problem with doing that. Why mightn't you want and let's say it's a reading study, a reading intervention study. Why might you not want to grab just the first students who arrive to the class that day?
They might be like the most eager and outgoing, and they might know the material best compared to the rest of the class. They could be like the top students in the class.
Absolutely. It could be something like that. Now, I'm not saying that's definitely the case, of course, but I'm saying you could get a bias sample that way, right? You could wind up inadvertently getting a bias sample. So this is one we try to avoid. So, you know, same with, let's say you're trying to open a new restaurant at the food court at the local mall, and you decide to stand outside of GameStop and just say, look, I like GameStop. I'm going to do some shopping there anyway. So I'm just going to stand in front of GameStop and I'm going to survey people who come out of the store and ask them what they would like better for this new food court, either a yogurt shop or a salads place. And again, similar problem with that, right? The problem is that in this case, well, I don't know if the people who shop at GameStop are necessarily representative of everyone in the mall who might visit a food court, right? If I'm just doing something haphazard or conveniently, you know, it may not work out. Now, having said that, sometimes we're forced. Sometimes we're forced to not get a random sample because of the nature of it. Think of rare disorders that you might be interested in studying. Let's say you're interested in studying quality of life of people who have a specific form of cancer. How are you going to gather that sample? Are you really going to be able to do it in a random way, or are you most likely going to have to maybe get onto a group, find one person, and then maybe use a snowball method, which we'll talk about in a minute, where you actually ask that person to find other people and find other people and so on and so forth, right? So we'd love to always do random sampling. You know, it's our goal, but we can't always do it. Okay, so let's talk about some of these non-random methods of sampling. A quota, where you identify quotas for individual groups and then you use convenience sampling to select participants within each group. I want 10 people who prefer chocolate ice cream and 10 people who prefer vanilla ice cream. And then I just use haphazard sampling until I get that amount. Purpose of sampling. I involve identifying a group of individuals with very specific characteristics, right? So sometimes you have to do that. Sometimes you have to look for specific characteristics because of the nature of your study. Snowball sampling, like I was talking about before, where you have research participants identify other potential participants, right? It's your way into a community sometimes. And it's particularly useful when it's a difficult to find population. Okay. Let's hold here for now. How about a 10-minute break? That sound good? I'm going to stay on in case anyone has questions that they just want to ask me, but feel free to scooch away for 10 minutes or do whatever you like, and then we'll come back and continue chatting. Okay, we're back on. So the difference between random assignment and random selection is that with random assignment, it allows you to show the difference between two or more groups or a relationship between things. Okay, that's more geared toward that. Whereas random selection, let's say you wanted to understand the prevalence of suicidality in the US Army. Well, then you better have a really good representative sample. Otherwise, your prevalence, your rate is going to be all wrong. But if you're just trying to understand, or I shouldn't say just, but if you're trying to understand whether amongst a group of people with dysthymia, for lack of something better, whether treatment A or treatment B is more effective, the random selection might not be quite as critical as the random assignment in that case. Okay, so we'll continue to talk about this issue, but two important pieces, random selection, random assignment, and they both have different goals. Okay, all right. And I have to click back on here. Oops, sorry. Here we go. So random assignment allows controlling for group bias. If you assign participants to the treatment control groups, without random assignment, you may unintentionally bias the outcomes if it's done improperly. Okay. A selection process could produce a disproportionate amount of highly skillful participants in one group, thereby biasing the outcome. Whereas random assignment, coin flip, lottery helps reduce group bias by balancing participants with exceptional aptitudes or deficits fairly evenly across the treatment control groups. Again, this is statistics. This is all about uncertainty and probability, so no guarantees here. You could flip a coin and still get a biased splitting of your groups, but hopefully you won't. Hopefully you won't, and you shouldn't. Most of the time it works out. Okay. Oh yes, so let me fix one more thing on this because I want to talk a little bit about randomness. So I'm turning on my sound here. Great. So I've done a lot of talking about randomness in the past little bit, and you might be wondering, you know, well, I can be random. Why do I need all these techniques? Why do I have to flip coins and put people in bags and all this kind of stuff? Why can't I just be random by myself? So this is a cute little video that hopefully starts to answer that question.
What's your number?
5164.
1365.
8888.
We asked 12 students to choose a 4-digit number, a number between 1,000 and 9,999 at random.
The number I've chosen is 5000.
1015.
My number is 7159.
And these are numbers they chose. What's interesting about these numbers, that if you look, most of them don't have any repeated digits. 1506, all the numbers are different. 2603, all the numbers are different. In fact, of these 12 numbers, only 3 have repeated digits. 8888, 5000, and 1015. Now, if you look at the numbers between 1,000 and 9,999, in fact, almost exactly half of them have repeated digits. So we would have expected, if we'd taken 12 numbers completely at random, to have had about 6 numbers with repeated digits, and we only actually have 3. And why is that? Well, the reason is that people tend to have a view about probability that means it is more uniform than probability really is. They tend to think that numbers like 8888 aren't random enough, and they tend to go for numbers like 1506. And in fact, in some ways, the most interesting number here is 1015, because it doesn't have the digits even next to each other. So it's, in some ways, perhaps much more random than 8888. If you want to choose a number for your PIN, for your mobile telephone, that's probably a good number to choose.
Okay, so cute little notion about randomness, and here's one more for you. And yes, with randomness, with random, we can never be sure that it's, if we're really getting random stuff. Okay, so let's talk a little bit about probability. That's what we've been aiming toward. That's where we're going. So let's get into it and start talking about the uncertainty within statistics. Okay. I have one more for you. The mathematical fortune teller, who's a little bit different from your average fortune teller. Okay. Probability. The likelihood that an outcome of interest will occur. The likelihood that an outcome of interest will occur. So what's an outcome? It could be the result of an experiment or observation. It could be a coin toss, heads or tails, a dice roll, a card from a deck. Okay. And we want to know the likelihood in any of these cases that this will happen, that this will occur. So even though I won't, like I said, we're not going to do a lot of formulas in here at all, but this is one I just want you to see. I just want you to kind of get a handle on, because it's kind of a basic idea of how we determine probability in general, and I want you to have that understanding. So how do you do this? You determine the number of possible successful outcomes or outcomes of interest, and you determine the number of all possible outcomes. Then you divide the number of all possible outcomes, possible successful outcomes, by the number of all possible outcomes. So, for example, you're flipping a coin with a friend. Coin has it's a fair coin, so it has two sides, heads and tails. Number of possible outcomes, 2. If you're heads, number of successful outcomes, 1, right? 1 over 2, or a half, or 0.5. Okay. Let's take another example. You have a jar that contains 100 jelly beans. 9 of the jelly beans are green. The probability of picking a green jelly bean would be what? I know it's on your slide set, but someone tell me anyway.
9%.
Yeah, 9%, or 9 over 100, or 0.09. And when we're talking, it's actually great that you bring it up that way, because when we're talking, and we'll get to this in a couple minutes, but when we're talking probability, we typically like to report things in decimals, whereas chance report in percents. So, yep, 9 over 100, 0.09, or 9% chance. Absolutely. So while we won't be doing really formulas, like I said, but I do want you to know some symbols. This is an important one. This is P. P is the symbol for probability. And like I just said, probability is typically written as a decimal, whereas chance is written as a percent. And to go from probability to chance, you multiply by 100. To go from chance to probability, you do the opposite, you divide by 100. Right? So if the probability of heads is 0.5, the chance of heads is 50%. Okay. Probability of 7 of diamonds would be whatever you get if you divide 1 by 52. Right? And then chance, multiply that by 100%. Okay. Multiply by 100 and you get the percentage. Okay. So that's the basic idea here. But like I said, probability is going to be at the core of everything we do. I'm sure you've read some scientific articles, and P has come up because you always see P less than 0.05 or P less than 0.01 or that sort of thing. Well, this is the P. This is the probability. What's the probability in that case that you made a type 1 error? And we'll talk more about, we'll get to all that, but it's the same P. It's the same idea. Okay. Range of probabilities. The probability cannot be less than 0 or greater than 1. Something with a probability of 0 has 0% or no chance of happening. Something with a probability of 1 has a 100% chance of happening. Okay. Now, we tend to lie in between 0 and 1 in statistics and in behavioral sciences. We tend to be somewhere in that range. Okay. Of course, then we have Honest Abe, who develops a sense of humor, much to the chagrin of proud stat students, where he lands on his side. Incidentally, it's not impossible for a nickel to land on its side, apparently. I learned this some years back. So there's some trivia for you. It's, of course, extremely, extremely low probability, but it's not impossible. Okay. So let's talk about some coin flips. And the way I want to talk about this topic with you guys is to introduce a game. So let's say you and a friend go to lunch every day. And you've decided with your friend that you'll flip a coin right before you go to lunch. And if it's heads, you'll pay for lunch. If it's tails, your friend will pay for lunch. Okay? So you flip the coin on the first day and it comes up heads, you pay for lunch, no big deal. Now let's consider some probabilities. Now you've played the game for 2 days, okay? And what are the possible outcomes that could happen on those 2 days? You could come up with a tail. That would be That would be cool because you get free lunch both days. You come up with a head tail or a tail head, in which case you each paid for lunch one day, or a head head where you paid for lunch both days. Okay, and then we can start looking at the probabilities associated with these different outcomes, right? So number of heads 1, we have that happened 2 out of 4 times, so half of the time. Probability of 0 heads, that only happened once out of 4, and probability of 2 heads, that only happened once out of 4. So hopefully you're getting the pattern here. Okay. One of the things I want to point out is that how this exponentially grows. Now we've only played the game 4 days. Well, look how many outcomes we have now, right? Now it's still most likely 6 here, and that you have 2 heads and 2 tails. So you've each paid for lunch on 2 days. It's getting a bit unlikely. If your friend has won now 4 days in a row, you might be starting to think, what's up? Because this only happens a little more than 5% of the time. Same if you won every day for 4 days, right? Your friend might be wondering what's up. Okay. Then let's say you go on, you play for 10 days, and then you go on, you play for 20 days. Well, this gets kind of interesting because the 20 barely looks like it exists. Now it does exist, it's not 0, but because it's so close down, you can't really see it here. So how many different outcomes are there from 20 tosses, 20 days of tossing the coin? And I'll tell you, it's over 1 million. So you see how that exponentially increases. The other thing I want to point out to you guys is we did a very dichotomous activity here, right? We flipped a coin, 2 outcomes. But by calculating the probability of heads and tails over 20 flips, what do we get? We get something that's slowly starting to approach the normal curve, the bell curve. And that's pretty interesting too. And we're going to come back around to that concept. Okay. So let's now switch gears from probability and talk a little bit about descriptive statistics. Okay. Again, any questions or any comments or anything like that, please feel free to pop in on the chat bar or what have you. Okay, but I'm going to jump into descriptive statistics in just a second here. Okay, all right. So I already kind of alluded to the fact that there's 2 branches of statistics. One is descriptive, right? We talked a little bit about what the descriptive were, things like the mean, the median, the mode, things like percentages, things like the min, the max, the range, etc. And it's used to summarize and describe a group of numbers from a research study. All the other stats I mentioned before, the t-test and the ANOVA and the MANOVA and the regression, were inferential statistics. These are procedures for drawing conclusions based on the data collected in a research study, but going beyond them. In other words, we're trying to go from sample to population at large. We're trying to make that specific prediction. Okay, this is what we found in our sample. Does it hold in the population? Okay, all right. So in order to be able to discuss descriptive statistics, let's make sure we just understand these basic terms here. A variable is a characteristic or condition that can have several different values: sex, race, birth order, temperature, level of stress, right? They can all take on different values. Whereas a value is the actual number or category that a variable can have. 0 to 10, being born first, second, third, fourth, etc. Temperature ranging from 90 degrees to 10 degrees, we'll say. Okay. And of course, data and datum. Okay. All right. We always talk about data. I just throw that out there because it's kind of fun. All right. So with that, now we can talk about the kinds of variables that we might have. So we're going to break this out into two pieces, and then we're going to break it out further into 4 kinds of variables. So first, let's break it out into nominal versus numeric, or qualitative versus quantitative. A nominal variable is a variable that has values that are names or categories, no natural order. Sex, race, ethnicity, political party, eye color, all nominal variables, because when you think about the values of them, you come up with names or categories, right? Okay. Numeric or quantitative variables are variables that have values as numbers, like birth order, I was born first or second or fifth. Like temperature, it's 10 degrees out, it's 80 degrees out. Like height, 5'2", 5'8", 6'1", or I could do that in inches or centimeters. Okay. So now let's break this out. Let's break these two out into 4. I'm going to leave nominal alone. I'm going to leave nominal alone. That's going to stay. That's still going to be its own category. But what I'm going to do is, because numeric is so broad, that's just a very broad way of speaking about things, we're going to break that into 3 other pieces. So again, this may very well be familiar to you, but let's go through it. So we have the acronym of, or the phrasing we can use of no oil in rivers. That stands for nominal, ordinal or rank order, interval or equal interval, and ratio. So I tend to use ordinal and interval, but other books and such might use rank order and equal interval. Okay, so let's talk these through. Nominal, again, that's the discrete categorical one. Numbers represent categories, hence you cannot perform traditional arithmetic on them. You represent categories that have no order. So, like for example, flavor of ice cream, chocolate, strawberry, vanilla. Okay, can you give me the mean of those? No, right? It doesn't make any sense. Religion, marital status, those are just some examples. Now, what you might be able to do with a nominal variable is say what % of people belong to each category. Okay, but if I told you that 3 people like chocolate and 2 like strawberry and 5 like vanilla, there's not much you can do in terms of a traditional arithmetic with them. You can't take a mean, you can't take an average there, you can't give me a variability or variance or anything like that. Okay. Ordinal. This is similar to nominal, but can be ordered or ranked. Here, the numbers represent categories, so you can't perform. That's bad. Sorry. Please delete that sentence right there. Numbers represent categories. That's not necessarily true, because it does represent categories that have order. So even though we can't, I mean, I don't like the way that's phrased. So like, for example, we can say education, high school, associates, bachelor's, etc. Small, medium, large, breakfast, lunch, dinner. So you could do that with it, but ordinal can also be firstborn, secondborn, thirdborn. Okay, so there is a natural order to it. And so while you wouldn't take a mean of these, there is some procedures you can use with ordinal data. Okay, there are some procedures you can do. So there is some arithmetic that can be done. So that's why I didn't like the way I phrased that there, or that was phrased. So yeah, again, please just get rid of that sentence. I'll do the same. So like, for example, when we were talking about the t-test versus the Mann-Whitney U, way back at the beginning, t-test for independent samples and the Mann-Whitney U, t-test for independent samples assumes one of these latter kinds of level of measures, whereas the Mann-Whitney U is if you have ordinal data, if you have ranked data. So there is stuff you can do with ranked data, okay, as long as there's an order to it. Okay, let's move on. Interval, numbers that are equally spaced. Temperature, such as 1, 2, 3. Temperature is -2 degrees all the way up to 95 degrees, or attitude, where you're measuring attitude on a scale of -5 to +5. Temperature, I'm talking about here Fahrenheit or Celsius. There's a reason I say that. There's a reason I say not Kelvin, if any of you are familiar with Kelvin, and I'll tell you why in a second. But here numbers are equally spaced, okay? So this is like a lot of rating scales we deal with are considered interval, a lot of stuff like that, okay? Ratio, the numbers that are equally spaced, but 0 is meaningful. 0 means nothing. You don't have any of the item. So like income, $0, no money. Height, 0 millimeters, no height. 0 weight. All these things make you think of there's nothing of that there. 0 coffee, right? You might be thinking bad day, but I'm getting at 0 milliliters of coffee, no coffee. Now, whereas with interval, the 0 does not have that meaningfulness. So with temperature, if it's 0 degrees out, that doesn't mean there's no temperature, right? If the attitude is -5 to +5, going from pessimistic to optimistic, 0 doesn't really mean no attitude or the absence of attitude. So that's the difference I'm communicating here. And that's why I said the Kelvin thing, because Kelvin, if you've heard of it, is like a physics term. It does have an absolute 0 temperature. So that would be ratio. But typically when we're talking about temperature, we're thinking Fahrenheit or Celsius. That would be interval. Okay, so that's your levels of measure. Okay, so the variable type, whether it's more nominal or ordinal, or whether it's more continuous, such as interval or ratio, also gives you some guidance as to what kind of test you're going to run. Just like I was sharing before, if you have an interval or ratio measure, you're probably going to run that t-test for independent samples. If you have an ordinal measure, you're probably going to run the Mann-Whitney U. If you have a nominal measure, we're into something else entirely, and it depends, like it could be a chi-square, depending on how everything else is set up. So you see how this actually makes a difference. Okay. So I'm not going to go through these right now. I'm just going to leave them here for you, but it does kind of talk about some of these issues, but we'll come back around to when you use each one as we go forward. But I think let's skip this for now. Keep it in your notes, but it's good stuff. But I think let's not worry too much about it quite yet. Okay, we'll come back around and talk more about how this applies to which test you use. So you'll be familiar with this before the end of the semester's out. Okay. Okay, so let's pull together some of what we've been talking about. Let's say you're conducting a study to evaluate how happy students are with their living arrangements. For this study, you asked 200 Westchester University College students to rate their level of happiness on a scale from 1 to 100. So I'm just checking in just to make sure we're all good, we're all on the same page. So let's start off with the sample and population. Could someone either unmute or chat in and say what the sample and population is here?
I was actually thinking about this when you were talking about it. So is the population just college students, but the sample is Westchester college students? And then is that like a convenience sample?
So this very well might be a convenient sample because I didn't say how you got it. So that's a really good point. And I'm glad you asked that question. Like, how the heck did you get these 200 Westchester University college students? So what I would say, though, in terms of sample and population, I would call the sample my 200 Westchester University college students. Those are the students I actually have in hand, right? So those are the ones I'm actually gonna get to do something for me. Okay, or did something for me because they rated their level of happiness on the scale. And then what I would call my population in this case would be, and this is again making the assumption that hopefully this is representative, but I would call it Westchester University college students because I didn't sample all college students, and we might see differences across different colleges in terms of how they would rate their level of happiness. So in this case again, I would call it sample 200 Westchester University college students, population all Westchester University college students. But I really appreciate the excellent point about the haphazard there. So if anyone wants to ask any follow-ups on that, please feel free and chat in or whatever, jump in. And then would someone tell me the variable of interest? What are we measuring here?
Happiness.
Yep, happiness, absolutely. And what type of variable, not level of measurement yet, just type of variable, so we're just talking whether it's nominal or numeric. What type of variable is that?
It's nominal.
Numeric, because it's measuring 1 to 100,
Oh, okay.
right. So it's numeric in this case. So good. So now we've eliminated nominal. We got 3 left. We got ordinal, interval, and ratio. So which level of measurement is this? Remember, it goes from 1 to 100.
Ordinal.
Could be ordinal, good call. Definitely could be ordinal, could be interval as well if you can argue that. Some people would put it in the interval category, some people would put it in the ordinal category, and I've seen both. It's how conservative you are with this. So yeah, both are acceptable answers, yeah.
Can you clarify why it wouldn't be interval?
Why you might choose ordinal?
Yeah.
Yeah, of course. So the reason you might choose ordinal is you might say, well, if they're doing a rating scale from 1 to 100, how do I know that the distance between 1 and 50 is the same as the distance between 50 and 100? Or how can I prove that the distance between 1 and 10 is the same as the distance between 10 and you get it? So that's why someone might argue it's ordinal. Like I said, I think most people in psychology honestly would probably wind up treating this as interval, but you could argue for the ordinal. I've definitely seen that. And honestly, it might even depend a little bit on the area of psychology in terms of where people fall out with this sort of thing. So you can have great arguments about this. Yeah, that's why it could be either one. Now, if you drew a number scale, here's how you might try to make it more interval. Let's say you drew a number scale and you measured it to be like 10 inches long, and then you chopped it and made, 100, 90, 80, 70. You might be trying to force their thinking into something a little more interval, your respondents' thinking. Again, this is all good stuff for argument, but it might help. I've seen people do that on measures. It's kind of an interesting technique. Okay, and possible values, I think we've kind of already come to this, that the possible values here are 1 to 100, right? 1 to 100. Those are the possible values. They're not able to answer 0 in this case. Okay. So any other questions anyone wants to raise at this point? Okay. All right. So nice. Good summary. Yeah, I think we're all on the same page. But if you're feeling at all, like you want to review something, chat in, write in, stop in my office hours, whatever you like. Okay, so let's just talk a little bit about central tendency, right? This is basically this finding the central point of a distribution, and it's a little bit different depending on which type of measure you use. The three most common measures, or the three I really know about, are the mean, median, and mode. So let's talk about those a little bit. The mean is the average value, and you get it by summing all the values and you divide by the total number of values. I think probably most of you are used to taking an average or mean in your life. If you've not seen this kind of formula before, I just want to show it to you again. Don't worry, you're not going to have to like memorize this formula, you know, but I just want to point out that X bar or M is what you want to remember as a symbol, or think of as a symbol that represents the mean. I've seen both. X bar is much more common. Well, that's not entirely true, because in articles they use M a lot. X bar and M, they're your two symbols for the mean. The weird looking symbol there is your summation sign. That means add them all up. X are the values for the variable, and N is the total number of values. So how would this work? If you had the numbers 1, 3, 5, okay? And what this means is add up the numbers let me point it out with my cursor. What this means is add up the numbers 1, 3, 5, and then divide by 3, because you had 3 numbers, okay? All right. So that's the basic idea behind this formula. An example of figuring the mean, if the scores for a particular study were as follows: 10, 5, 9, 8, 6, 5, 9, 8, 7, 6, 5, 6, you would add them all up. You would get 84. You would divide by 12, and you would get 7. Okay. And depending on which journal you're reporting to would probably depend on how many decimals you might include in your study. Okay. So, and something else you want to know about in terms of symbols is that for a population, the symbol for the mean is mu. The funny looking U is called mu, whereas for a sample, it's X bar or M. Sorry, that bar got moved over a little bit, but it's X bar, X with the bar on top, or M. And for a sample, for a population, we typically use capital letter N to represent how many are in the sample. And for a sample, we use little n to represent how many. So for population, N is how many in the population, little n, how many in the sample, okay? Sorry, I kind of said that backwards for a second there. So population, capital N, sample, lowercase n. Okay. One of my favorite cartoons. Seems that no matter what I do, I'm always just average. The perturbing part to the cartoon to me is not why the mu has lips or anything, but why the pill bottles are like spilling over and floating through the air and all that kind of thing. But anyhow, I guess I've seen this cartoon too many times. All right. Median. Median is simply, it's going to sound really complex, and it's not. It's your middle number, right? It's your middle number. Just like median strip on a highway, you're looking for the middle. Okay, so I know this is a lot of words to say middle, but you basically line up your scores from lowest to highest. If it's an odd number of scores, you just come into the middle, find your middle number, you're done. If it's an even number of scores, you come into the 2 middle numbers and take the average of those. Okay, all right, so that's all you have to do. This is another funky way to find the median. If you like it, you can always do this method. But I don't know, I just kind of go to the middle typically myself, and then either find the 1 or 2. Okay, all right. And then for this group of scores, the median is, of course, 6.5, right? Because we had an even number, so we had to go between the 6 and 7, and we got 6.5. Okay. Mode is the most common value in a distribution. Mode is the most common value in a distribution. Okay. It's usually what we might use to describe a nominal variable, right? Most common was vanilla. Most common preferred ice cream flavor was vanilla. Okay. And so for the top group of scores, we can see that the mode is 5 because we have the most 5s, more 5s than anything else. For the bottom group of scores, it's 5 and 6. So you can have multiple modes. That's the point I'm addressing here, is that you can have multiple modes. Okay. All right. So here is our little price example. We have 8 grocery stores that sell this PR Energy bar for way too low a price, and the idea is to find the mean, median, and mode for these prices. So if any of you would like some practice in doing that, I have the answers just coming after that. I think I'm just going to kind of go through them with you guys rather than have you actually do the activity. But if you'd like to, please feel free to take this as an example that you can work out. Okay. All right. So of course, for the mean, you would take all the prices, add them up, divide by 8, and you get 1.41. For the median, you'd sort them and then go between the two middle values and get 1.37. And for the mode, you would get 129 because that price occurs more than any other price. Okay, all right. So what's more interesting, perhaps, than the actual calculations of the mean, median, mode, because you can get all these off of SPSS, the median is better than the mean or mode as a representative value when a few extreme scores would strongly affect the mean but not the median, right? So it's when you have outliers, when you have those extreme values that's much higher or much lower than the others. That's when you want to think about using a median rather than a mean, because that mean is going to be thrown off. Okay. I'll share a quick example of why I argue it's so important to look at your data when you first get it rather than jumping in. So that suicide study, that suicidality in the U.S. and soldiers in the U.S. Army study I was kind of referencing before that I was involved with. So we first get the data, and it's like 1.6 million records, right? So we're not eyeballing this data. And we start looking at it and we figure we'll just look at age. Let's just start with something easy. Let's just look at age, right? So we look at age and we see that the mean was coming up kind of high, considering what we would expect from this population. And we're like, well, what's going on here? Well, we saw when we actually started looking at the data that it looked like, and this was supposed to be active duty soldiers, right? We saw some active duty soldiers listed there whose age was over 200 years. Problem with the data. Had that, of course, so in this case, we wanted to get new data, and we did, and we got a better answer and that sort of thing. But when you have extreme values that are real, that make sense, consider the median. Okay. So here's a little outlier example for you. You have 5 graduating seniors on a college basketball team who receive the following first-year contract offers to play in the NBA. 0 indicates the player did not receive a contract offer. So we've got 0, 0, 0, 0, 3.5 million. Okay. The mean contract offer is 700,000. But if you ask yourself, is it fair to say that the average senior on the basketball team receives a $700,000 contract offer? You would most likely say no, that's not really fair. That's not really accurate. We should probably be reporting the median here. Or doing something different other than reporting the mean, right? Okay. Here's a nice example for you, a bimodal example, because in this case, even though it is numbers, and I said before, it's most of the time you want to use the mode with nominal. But here's an example where I might use the mode again. Because if this is like exam score grades, let's say, right? And there's a bunch of 1s and a bunch of 99s, I don't really want to report the mean or median of 50. I don't want to do that because there's not even a 50 in my data. There's not even anything close to a 50 in my data. I don't feel that's very representative. I don't feel it's a very helpful descriptor of what was really going on in my data. So this is a case where I might want to use the mode. Okay. And just to point out why measures of central tendency are not really enough, they're not really sufficient to get us where we're going, look at this. First set of data is the one we've been looking at, 5, 5, 5, 6, 6, 6, 7, 8, 8, 9, 9, 10. Second set of data also has 12 numbers, 6 zeros, 6 14s. Very, very different data sets. And even though they both have a mean of 7, I would say I wouldn't want to just leave it at that, right? I wouldn't want to just say, oh yeah, they both have a mean of 7. They're both pretty much same data sets. There's more to it. There's more to be uncovered. And that's when we get into frequency distributions. So let's just start our way through frequency distributions, and we won't get through all of the material today. Let's cut at some point, and I'll show you where, of course, and we'll cut at some point and then continue next time. But I want to start off talking just a little bit about frequency distributions with you guys. Okay, so here's our example of when central tendency is not enough, right? We can see that if you look at the average temperature in Oklahoma City, it's a lovely 60.2 degrees. But when you start looking at the highs and you start looking at the record lows and you start looking at all the stuff, you start seeing that, hey, maybe this isn't such a moderate temperate place to live, right? So just a small way of trying to show that we want to be aware of not only just what's going on centrally, but what's going on with our data in general, with the shape and range of our data in general. Okay. So one way to make sense of data is to look at frequencies, the number of scores with a particular value, or a frequency table, which is the table that displays the pattern of frequencies over different values. Okay. So here's our frequency table setup, right? If we had happiness ratings from 0 to 10, we would simply see how many people rated a 0, which was 0, how many people rated it a 1, which is 2, how many people rated it a 2, which is 3, and go on and on and on. Then we could actually take the frequency of each number, right? By taking, I'm going to move my little, sorry, I have something in the way here. That's better. Okay, so I would take the frequency, let's say 2, over 20, and I'd get 0.10 or 10%. So we have our relative frequency, which is the same as our probability in this case, right? Because it's the same kind of calculation. And then we have our percent, 10%. Right, so same idea. That's how we would actually create a frequency table. Again, I'm just showing you the background to this. This is something you can get out of SPSS. Okay. And I have to click back in here. Okay. Here's another type of frequency table you've probably come across in your existence. This is a frequency table for nominal variables. This is kind of a interesting study where they actually, post 9/11, they had a registry where they were measuring mental health symptoms. And basically this is some of the data out of that study. Okay. All right. So same sort of idea, we just have names on the left rather than numbers. And of course, if you have a whole bunch of numbers, you might bin or group your frequency table, right? So like if we're thinking of bowling scores or anything where you're trying to get frequencies, but you don't want to list out, 1,000 numbers on the left or what have you, excuse me, you might group or bin the frequency table. So we might put together for bowling scores 0 to 50, 51 to 100, 101 to 150, etc. Okay, so then once we have our frequency table, we might choose to get a histogram, which is a graph of the information on a frequency table. And the height of each bar is the frequency of each value. So let's look at this. Here's our table again, right? With our happiness ratings, our frequencies, our percents. And here is the corresponding histogram. So what we did, let me just show you. We took this 0 to 10, we put it on the bottom, 0 to 10. We put our frequencies along the side here. I keep pointing as if you can see, that's helpful, sorry. So you got your frequencies along the side, your values along the bottom, and then what you're doing is you're simply plotting out, okay, 2 people gave me an answer of 1, 3 people gave me an answer of 2, and so on and so forth. Interesting point is that when you are doing a histogram, the bars should touch. Okay, so here is kind of a false representation because as opposed to having my scale on the left go from 0 to 4, I went it go from 0 to 100. So it makes this look entirely flat, which it shouldn't. Here's one more example of distorted histograms. And this is just a little way of my sharing with you that, you want to be careful when you create your histograms. You want to be, you want to give a representative finding. And it is a little bit of a matter of judgment. I know you're probably wondering like, okay, so I get it from this obvious example that this one smushes it down, this one expands it out, this one's probably just right. But how do I know when I'm creating a histogram? Again, SPSS will kind of do that for you. So if you have your data set up correctly and you have your ends figured out correctly, most of the time it will do a nice job, but you should always kind of be aware of those kind of things. Okay. So how about if we stop there? Sound okay? Please pop in. I'm going to hang out for a few minutes after. If you have any questions, please feel free to pop in. I will open up the assignment area for your first homework, and that will be due next time by class time, okay? So next week by 4:25 is when you want to have that submitted. So please get that in, and if you have any questions or anything else, please feel free to let me know. It was a pleasure meeting you all today. I wish you well, and I'll see you next time, unless there's any other questions.
I just had a question about the homework.
Of course.
I was just looking at it really quickly in the format. Do you want us to like write it in a Word document and then upload it, like transfer the answers to a Word document?
That's what I would do. I would use a Word document. Yeah, that would be perfect.
Okay, great.
Okay, sure. Absolutely. You have a good one.
Thanks, you too.
Okay, bye.
Bye.